Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, well, I'm gonna be finishing the syscalls since I can't really make the C standard without it. Though I'm not really sure if my goal anymore is to recreate the C standard in this project, or maybe we'll just wing it. But when I implement the syscalls, I'll probably just make it a time lapse or something. So let us start by going to the syscalls table. And then seeing how many I've implemented as a syscall here in Unix standard, or maybe I'll restructure this right now. So I'll remove a few things. So inside source, I'll be removing Erno, miscellaneous. No, miscellaneous is still needed. But the C standard, I'm not sure I'm doing that right now. String, then the Unix standard. And then what else? I'm gonna need the internal syscall. So move src miscellaneous internal syscall source. I'm not really sure how I'm gonna structure this right now, but let's see. Syscall, then how about I make something like architecture? Then for miscellaneous, we can remove that. Then inside syscall, these are the implementation, but that needs to be in Arch. So, oops. And this should be x86-64. And next, what's inside the sys folder? Oh, it's that. Can remove that. And this as well. And here in internal syscall, we can move that to Arch. And for the Linux syscalls, we can create a sys folder and create a Linux folder. And this will be our syscalls folder for every syscall in Linux. So we can finally start with the first one. Though how many are there even? That is quite a lot. So 335. So the first one is read, and we'll be adding that. And where do I need it? Yeah, I have not put it in the search folders yet. So compile flex. So -I and src arch. No, that should be fine. I believe. There you go. There it is. And when implementing read, I need SCA and read. Though maybe I should implement this as something like this instead. Yes, there you go. This needs a file descriptor. So I'll just be copying the types here. Though, do I even need to have this as the syscall type? Just makes a long value and a buffer and a count. Though we don't really have size t yet. And maybe I should have a central definition for this. So make the IR in include. And instead of sys, yeah, this could be something like integer.h or something, not make the IR. So we'll have various type definitions. So first, we will define an I32 to be an int. Should be right. Yeah, it's an I32. Well, at least on this machine. And I64 is a long integer. And an I16 should be a short, I believe. And an I8 should just be a character. And to get the unsigned version of this, oh, this is still in the same directory as that. So that's wrong. This should be integer.h. Though, yeah, there it is. I should remove that. No sys and the standard. Oops. Syscall and Unix standard. There. Then to have the unsigned versions, I'll just have a macro do it for me. So type unsigned and we'll replace this with a U. Then go down, then just redo it. Though, yeah, I did not anticipate that. Oops. But that should be it. And in here, this should be an unsigned U64. Though, maybe I need something that is platform independent. So I need a U size and size, I size. And should be I64 and U64 respectively. Though that depends on the architecture. Maybe I will add something else later. So integer h, then define it, then close it. There you go. Now we can include syscall internal and we can include integer.h. So this should be a U32 and a U size. And we can call syscall. Lower is the macro for it. I don't have syscall return anymore, so should be just this. So it's this one. And I need read, so it should be 0. Then file descriptor, buffer, and count. And we can just return this. And that is what we'll practically do in most of them. So split 001 should be right. That's C. It's practically the same thing. Now that I think about it, I would also need to have the syscall numbers as macros and put them inside the implementation so that when something changes, I don't really need to open the files themselves and just this one. So I gotta copy the syscalls and do some regex magic to make it what I want. I've been struggling at this for around 2 minutes now, though I think I may have sped it up in editing. So I'm just gonna go in regexer and see what I can do. Well, there are some duplicates that happened, so maybe the regex wasn't fully right, since I guess there's supposed to be numbers here in the syscall names that was removed and became duplicates of the earlier ones. Next up is actually defining the syscall functions, and this will prove to be more of a challenge since we don't have all of the data types that are used in the syscalls, and some of them are maybe deeply integrated in libc itself and not in the Linux headers. But we will try anyway and just copy paste the structs that we cannot find in the Linux headers along the way. And then for the functions that are somehow different, that doesn't have the data types in libc or the Linux headers, well, we will just check the manual page for it and hope that there's something in there and just mark it as differing uh, definition in the headers from libc and here in this list, and just hope that we get the right one. Now that is done, we see that I'm missing a few stuff, specifically sac adder and message header that is used by the socket API. But unfortunately, it's not defined in the Linux headers and is only defined by libc. So we'll create our own, I guess, or just copy it over. So split include socket.h, though no, it's not in here, it's in sys. So I need the message header, which is over here, and copy this over, or is it in the man page as well? It is. So we'll just copy this one over for sac other and message header is over here. And I'll mark this as a suspicious struct definition, since I'm not really sure about this. So there's the message header, and here is suck adder. To do sus paste, and as a family, let's see where that's defined, or maybe it's also defined by libc. Who knows? Family T. Oh, it is defined by the Linux headers as well. Though it's as the kernel type. So let us do that. So type dev kernel as a family, or secadder family T as a family T. There. Now there are 4 warnings left. So this one might be a typo from the site or incorrectly copied over. So let's check. Man to bind, I believe. Yes, it's a suck adder. Now I need the other message header, but it's though it doesn't exist, surprisingly, in the manual pages. But here in socket H, here it is. But it's a GNU thing. Well, it doesn't really matter, since the syscalls use it as well. So with this, we have defined the syscalls. Now we need the implementation. Though, where is it? Suck adder definitions. Yeah, we can stop that now. Oops. And the suspicious track definitions are here. So, okay, that is done. Now, let us continue on with the time lapse of me implementing the syscalls. Wait, now that I think about it, I've also defined these macros later on in the time lapse back then, and I didn't really use it here since I've made this first before it, so it's time to use it. Though I have sys over here, but I defined sys Linux, so I've done it fairly wrong. Also, there are some that does not start with sys, and I gotta find that so we can grep it. Inverse I size sys dot star in src sys linux. No, it should be in include, my bad. Sys linux syscall h. There you go. And I'm gonna remove the ones that start with spaces, or maybe not. Well, this is fine as well. Or maybe we just grab the ones that start with I size. Yeah, we should just grab the one that start with I size. Though, am I doing something wrong? Should I put a backslash? Oh, well, it's fine. Oh, grab dash v. Yeah, that's on me. I did not even read it properly. I size. There you go. Stub. Add sys on its starting point. And oh, it's at the end one. So I size sys. There you go. Well, I did not even do it right. There you go. And select everything. And replace sys with sys Linux. There you go. Now it says there are conflicting types since no, this needs to be an integer. And where else did I actually do this? Ah, well, this should be I size as well. So with this, we can start the time lapse now. So let's go. Now that I think about it, I should just create a bash script that would take the function names and their arguments and just put them in a implementation syscall, since it's mostly the same, though I'll maybe struggle using awk, awk, and the other tools to create the output that I want, but we'll try anyway. If we run this, Okay, there it is. So changes in types from here will be done over here. Okay, now that's done, well, we can go to Nobita. For this is bound to go wrong. So first, our sources are in architecture and x86-64, then sys Linux. So they are both 2 levels deep, so that's fine. I can add this to that, and I'm gonna rename this as unstandard C now. And then let's see. Yeah, that's fine with the C runtime. And hello doesn't really have anything, for it's gone. So let's recreate that with test and split test. Hello, let's see. We'll just write out the things for now. And why not create a certain strlen function for now that takes a character, but it doesn't really change it. So while this is not null, and this should be the return value, so 0, return ret, and oh no, that should not be a while, but a for loop instead. For stir plus plus ret plus plus. There. And we can declare the syscall via sys linux syscall. And these writes are sys linux write. Now we will see if this compiles properly. So ls make build and run build. All right, the headers. I do not have that yet. So the only headers that I have are 2 of them. That is sys slash linux slash, oh, there's 3 of them, types.h, sys slash linux slash syscall dot h, and one more thing is the integer.h. There you go. Then we'll see if this builds properly. There you go. Zero size array in open and types H F handle. Wait a minute. I gotta open that just in case. I'm not sure what happened. Oh, to open. Huh. Well, not yet anyway. But what happened in a beta build? Loop. There's nothing. So something has gone wrong. But it did find the syscalls and well, where's the actual syscall itself? Oh, there it is. There's the failure. I did not even see it properly. So it could not find internal syscall in syscalls file. So arch, I forgot that I've actually changed this. So this is now sys slash linux slash syscall. There you go. And now let's rebuild it. There's gonna be a lot of warnings for that F handle. And it was undeclared, huh? Linux wait for. Well, we gotta define that. Is it this one? Number 61. There it is. And what else have went wrong? execve has the wrong argument. Well, I did not really see that or deal with that with the substitution back then. So where is this? Number 59. And oh, number 59 only. Oh, 59, execve. And that's that. Let's try again. There's still something failing. So where are we now? This one errors out from number 66. Unknown operand type of this thing. Oh, we're trying to turn it into a usize. Well, let's check the man page for it just in case. So This is a union. Mhm. Yeah, I'm not really sure how this should be done. So, well, what was the definition of this? Um, user include Linux sem.h and sem un. So, pointers and a value, which we can just probably turn into a long value. It's a union anyway. So use signs a and the argument of the buffer cast into usize. And let's hope that this does not trigger a bug later on. I should add that here in the include. So semctl to do possible bug when casting union into usize. There. And it is now doing something, but it still failed. Here in umount, it actually has a number, eh? All right, one more. Another error. Yeah, it's the numbers. 64. What else? Select 6. Oh, I see that error. BR limit this time. 64 again. Maybe this will be needed to be moved as well in its own architecture directory. Sys Linux, right? Okay, now the problem is in our build system. We do not link into the correct C library. It's now named unstd-c, and I forgot to change the C runtime to call sys linux exit group. There. Now let's try building that. And it goes into our unstd-c. and it prints out the arguments. Hey, hey. All right, the syscalls are done. Well, fully done with possible bugs. And with the to-dos, I'll leave that later. And for the next one, I guess I'll try to make a configuration header that everything in unstandard C will be based on. So thank you for sticking with me this far, and may I see you on the next one.